to another session of Oregon Modeling User Group meeting. And my name is Leming Wang. I'm an associate professor at Portland State University. I, along with Kyle and Garth, I'm one of the coordinator members of coordinating committee. We will talk about, we will have a shift of guards. We'll talk about those towards the end of today's meeting. So Oregon Modeling User Group is a kind of a subcommittee of the Oregon Statewide Modeling Collaborative. Its purpose is to, as a platform for information sharing, open to modeling professionals in public and private practice statewide. And so for today's meeting, we have, maybe next slide, we have two great session on the topic of modeling policy and performance measure. I will introduce the speakers before each session, and then I will close, have them present, and then have you ask questions and so on, and then we'll close with announcement and a closing remarks. And that is the agenda. And for
you want some? Hold on, it's some at work.
Okay, maybe please remember to maybe mute your mic. And we'll begin with a lightning talk. So for the lightning talk is it's something we bring back. I believe Kyle experimented with it a while back, and then I do think it is. We all think it's, I think, a pretty good add-on to pretty much every meeting. It's a short 5 to 7 minute update presentation on recent projects, modeling applications, or any other topic that might be of interest to this group. So we are always soliciting volunteers to do those lightning talks. Since we don't have any volunteer this time today, so I will be doing a brief presentation on interactive mapping with R or in R. So kind of following another lightning talk I did a while back on the Perl or function modeling in R. So I hope those will be interesting. So if you feel those are not as helpful, certainly volunteer. And then you can talk, you can share a bit more of your work or any tips, any information that will be helpful to this group.
Leming, before you get started, we have a hand raised from Cody. Should we take a question?
Yes, I didn't see that. Cody, yes, go ahead.
I was going to volunteer, and I could be less than a minute if that's okay.
Sure, I can share. Oh, I can run through my slides rather quickly, and then you'll have a minute of your time. Sure, that's fine. Okay, I will share my screen. So we have a amount of time. The entire screen. Which one? This one here. Share. Of course, I have it on my screen. That's something that this is what. So, come on. Right. Okay. So, what is interactive mapping? So, I believe for those R user, or for that matter, Python or any programming user among you, you probably have create figures, maps in your work. So there is a difference between a static map, static figure, and a dynamic figure. So a static is basically a picture. There's nothing else you can do. Here is an example. I created a static map that supposedly shows the, I believe, population density in Monoma County. Of course, there's no reference and so on unless you know the shape of Monoma County. It's a bit hard to know what's going on. And then, so here the issue, I suppose it works, but I cannot be sure since it's maybe just a bad choice of the legend and so on. So it's all pretty blue, dark blue here, but there may be something in downtown Portland and so on. So this is where a so-called interactive mapping will be helpful. So I can zoom in or actually click on some of those block groups to show the value to validate whether it is just a poor legend choice or is something wrong with the data I have. So of course, without kind of doing it interactively in R, the fallback typically actually is part of my workflow as well, is I have to open up a QGIS, ArcGIS, or other GIS software to actually zoom in, pan to that area to check the value and so on. So of course that works. It's just that it is not a very smooth workflow. You have to jump in and out of R or whichever working environment you have been in. And then you have to save your data into shapefile or other format that you can open up in QGIS. Alternative is you can do it interactively, even with inside just R. Of course, if you're using R Studio, VS Code, and so on, so that works pretty fine. So with just 2 lines of code, here is the same map that I created before. So as you can zoom in, pretty much similar. Of course, they flipped the legend a bit compared to before. And I can see actually it does have variation. It just looked like it is a poor legend choice in my previous static map. And of course, you can actually host this interactive map on a website, render into HTML file, and so on. So talking about doing interactive map, hopefully you get so that this is a good thing to have. There are many different options for doing interactive mapping with R. So those, the few that I highlight there, they're both based on different technology. There are Leaflet or WebGL and DeckGL are a few different underlying technology. They're all based on HTML, JavaScript, and available on a browser. So a few I highlight there is MapView and TMap and MapGL are the one that I think personally I prefer. I already give you an example of MapView, and let me give you an example of TMap. So TMap, the neat thing about TMap is that it supports both static and interactive maps. So of course, this is an interactive map created use TMap, and then you can create a static map. You can include it in your report and writing up and so on. MapGL is final option. It's a new kit on the block. It is pretty powerful in that it uses WebGL, so it's more efficient with larger data set. But the syntax is a lot more verbose. Its creator is Kyle Walker, the same creator for Tidy Census. So given the caliber, his caliber, I believe this will be, it's still evolving. Given its caliber, I believe it will be a pretty powerful tool in the future. So yeah, that's all I have. So give it a try. For those R user among you, I believe there are alternatives in Python as well. Okay, with that, I'll probably Cody, I'll give you a minute to share whatever you have in there.
It looks like maybe you had a question from Joe.
Josh, let's bring this offline since for lightning talk, we promised that we will not do Q&As to kind of reserve the time for the main part of the session. Go ahead, Cody.
Okay, thank you. Just wanted to share that DLCD in partnership with WashDOT applied for a U.S. Climate Alliance Technical Assistance Award earlier this year, and we received it. And what we are doing in partnership with Washington, Colorado, Arizona, and New Mexico is creating a greenhouse gas emissions reduction handbook based upon the California CAPCOA guides some of you might be familiar with. So specifically kind of making it more of a Western states version, and it's got a huge section on transportation and a lot of VMT reduction activities that will be customized based on Oregon fleets and policies. So we'll have like lookup tables and you can, it'll be a really good resource, I think, for doing project level analysis on VMT and GHG reduction. So I've got Elliot Rose at Metro is coordinating that group if anyone wants to talk to him in Metro, and then Brian and Tara from ODOT Climate Office. I think Morgan Schaefer at DEQ is coordinating that group, and then Amy Schlesser from ODO, and then I'll be kind of herding the Oregon cats on getting our joint comments. So if anyone's interested in participating, reviewing any materials, just please let me know. And I've got a link to the California version that we'll be modifying with our contractor ICF, who wrote the original, and we'll be working over the next, I think, 6 months.
Great, thanks, Cody. Okay, now move on to our main session. We'll begin with the presentation on Metro's mobility policy. Joe and Peter will provide an overview of Metro's new mobility policy, focusing on analysis method used to evaluate the new standard and prioritize area for investment. Our two presenters, Joe Broach, PhD, has more than 15 years of experience in transportation research and planning in both academic and public agency settings. His work on active transportation modeling, behavior, and data has been widely published and included in federal guidance. Joe's current role including transportation modeling at Portland Metro, research and teaching at Portland State University, and chair the Oregon Modeling Statewide Collaborative Travel Survey Subcommittee. Peter Bosa is a principal researcher and modeler for Portland Metro, where he oversees transportation model development and application. Peter has more than 15 years of experience in transportation research and modeling application. His recent work includes several dynamic traffic assignment model deployment in the Portland metropolitan region, including the I-205 tolling study, interstate bridge replacement, and upcoming West Side Corridor multimodal study. Peter also serves as vice chair for the Oregon Modeling Statewide Collaborative, working with other transportation agencies to help ensure Oregon has the right data, tools, skills, and expertise needed to answer important questions about our transportation systems, land uses, and economy. With that, I will give the control of the room to Peter and Joe.
Thanks, Li-Ming. And hopefully you guys are seeing my screen now. All right. Well, it's always a pleasure to be at OMUG. I have learned so much from this group over the years, and it's always fun to find ourselves on the agenda. And I think we've got a fun one for you and a fun version of this presentation for us. And my colleague here at Metro, Peter Bosa, is joining me. And so what we want to talk about today is how we modeled a new measure of throughway performance for Metro's updated regional mobility plan. And for this group, we've done a number of presentations around the policy development side of this work, but we wanted to really focus in a little more closely on the data and modeling that it took to support this more flexible way of measuring our plan's performance. So just to overview what I'm going to talk about, so we have developed this new speed-based highway performance measure, a bit of a departure from the past, and it's actually part of a kind of a package of regional mobility policy measures. It's not the only criteria or even the dominant one, but it's the one that is really depends on the travel model and other data for support. So I thought it'd be of interest to this group and those that are working in that area. Another thing that makes this work sort of fascinating is that it's one of the first times that we've done a real fusion, a melding of big data sources via INRIX speed data and travel model outputs. And I think my view is increasingly this is going to be the direction we're going as modelers supporting planning and policy, that the cheerleaders of big data were often making the push that it was going to replace our kind of old outdated ways, but the reality is that they provide two different sets of tools usually, and often one is more suited to one thing than the other. And I think more often we're going to find ourselves kind of triangulating and fusing data sources and our travel model outputs, and this is a great example of that. And we really wrestled with it for quite a while to figure out how to make best use of both. And then finally, just I always think that models need exercise. If you keep them locked away just like a person and they don't get out and about, they tend to get stale and accumulate issues that you're not aware of. And so it's always good to stretch the model a little. This is a use case we haven't really had before, and you learn a lot about the model, and we try to feed that back into our model development plan to make improvements. It's just great information that it gives you when you try a new application. So for those unfamiliar, and I think most of you in this room are probably vaguely familiar with the old way of measuring regional mobility, which was pretty closely based on volume to capacity ratios. It's about kind of right-sizing the system, and it as the RTP updates, especially in the metro region, went on, it was less and less a useful tool for measuring progress. It was just too narrow in focus. It wasn't multimodal explicitly. It was too blunt of an instrument, and honestly, as you see with these RTP targets that were not being met toward the end, it was just like it was like a gauge on your dash that's pegged at the top, and at that point it's not really providing you information about which direction you're heading. It just sort of says pull over now, and that wasn't. Yeah, that is an example of a performance measure that's not performing well, frankly. So, and I don't want to minimize the huge process. This was multiple years, 2 or 3 years of background research, stakeholder input, public outreach on developing this plan, and so a lot of thought went into this. This wasn't just us, playing around with what we could do with the model. We were really in a supporting role here, but you can see, from volume to capacity ratios to this mobility policy, that's a big leap. And what I'm going to be talking about today is just one sort of leg of this new mobility policy, which is meant to be much more holistic and better match measures to policies and goals. And the one I'm going to be focusing on is the fourth one on that list. I'll give you a link later for those of you that are interested in other parts of the mobility policy and maybe haven't been as closely attached. But we're focused on this measure of maintaining reliability, quote unquote, on the region's throughways. And obviously, it sounds easy to someone who doesn't work in this arena. For those of you that do, that little phrase is fraught with lots of options and challenges to get to that point. And so the three major bins here, again, so the primary target or policy measure is VMT per capita. And there are secondary measures on system completeness and this reliability of throughways measure, which I'm going to be talking about. And these secondary measures are really they're not used so much for target setting that we're going to maintain a certain level, but they're used as a better way, like I said, to give us a gauge of where we have the most needs and opportunities for improvement in the system, knowing that we can't do everything, given funding and other realities. Where should we focus our attention, or where do opportunities exist to really to make a difference with scarce resources? And so in this reliability of throughways threshold, I'll tell you a little more about how those throughways are defined in a bit. But the threshold that was established, and this was in close coordination with our friends at ODOT, and like I said, a lot of research and input, was 4 or fewer hours per day that average throughway speeds drop below 35 for controlled access like freeway, or 20 miles an hour for a signalized arterial or other route in the region. And the idea here is related to the old goal, which was providing reliable travel speeds, for outside of the peak periods for goods and people to move. So that's there's an accession here. We recognize that we're not going to be able to meet level of service whatever necessarily throughout the region, but we want to do our best to make it as efficient as possible, and particularly as reliable as possible, so that there are hours of the day where traffic is moving with stable flows, and you can have an expectation of how long something's going to take. So how did we do it? And this is where we realized we needed to merge some data sources if we wanted to do the best job we could, because like I said, we're stretching the model a little bit. A regional travel model obviously is not, its primary design is not to get speeds on an individual facility at a given hour of the day, right? That's a stretch. So we wanted to bring in some observed speed data to kind of give us more of a grounding in reality. So step one, of course, is defining what we're looking at, what we're measuring, and where we're measuring it, defining the throughways, and that's defined through our regional transportation plan process. From that, though, we did needed to segment it, because these throughway corridors are really long, and there's a lot of variation within them on how the traffic flows. We had to create analysis segments, and then fuse these two data sources, and the two sources were observed speed data from INRIX, provided by ODOT via the RIDIS platform. I know some of you are familiar with that. But of course, that only gives you what's happening right now. You can't go into INRIX and query 2030 or 2045. And so we also needed to blend in regional model estimates of how those congested hours a day might change from a base year to a future scenario. And so blending those two together, we get a sense of current performance relative to this new reliability metric, and also projected performance in the future. So like I said, the RTP policy designates what the throughways are, and there are two big bins, as I mentioned. You'll see in the blue are the controlled access, mostly freeways in the Portland metro region, and the lighter, the pink color there are the signalized throughways that have driveway access along the way, and signals that break up the flow of traffic. The observed data, that's the probe data, for those of you not familiar with it, from provided via INRIX, and it's attached to his own network, right? Not to our planning network, of course. It comes on this kind of Byzantine traffic messaging channel network, the TMC network, that has its breakpoints based on where, like a navigation system would want to tell you to heads up for an exit coming up or something like that. But it's not the same as a modeling network for sure. You can see the kind of oddly spaced breakpoints here. This is I-84 east and westbound near downtown Portland. And this is kind of what it looks like for single one of those TMC links. So this is one of those I-84 links I just showed. And over the course of a year, we looked at all non-holiday weekdays at 15-minute interval VINs. There's some data unavailability. And that leaves you with the question, well, here's your data, but how do we translate that into this performance metric, which is how many hours per day is this link below this threshold? And you can see it's going to vary day to day, right? Sometimes in an hourly bin, traffic is moving along above the 35 mile per hour threshold. Some days it's below, sometimes it's about a 50-50 split. We have to kind of define a metric to summarize that. And so we ended up calculating just the average weekday hours under the speed threshold for each of those TMC links, but the links still need to be aggregated for analysis. This is this was seen as too fine-grained and also subject to quite a bit of missing data in the probe data, and also getting to be well below, I would say, the model's sort of threshold for being able to define speeds on a segment. So at first, we started from the simple one, which was just freeway, the regional throughway definition, but these are very long, right? So that takes that and summarizes it basically all the way from 205 to the junction with I-5 on east of downtown, and you would get a single metric by doing a weighted average of those hours under the speed threshold. And in this case, westbound was not meeting the threshold. It was over 4 hours a day. Eastbound was, but that masks obviously a lot of variation along the way. So we worked with ODOT and with our consultant partners at DKS, and we tested a pretty good list of different strategies to segment the network for analysis. And in the end, we settled on a pretty simple one that was understandable, seemed defensible, and wouldn't require us to do too much tweaking over time. And that was just to go off-ramp to off-ramp for the controlled access freeway facilities. It sort of makes some logical sense that those define analysis segments. On the signalized throughways where you don't have ramps, then we typically would go major intersection to major intersection, but as I'll mention later, it's still kind of a process under development for those without access control. It's a challenge to normalize them. They're so locally dependent. So finally, to the punchline here. So how did we meld these sources together? Well, we took those analysis segments. We looked at the observed hours from the probe data not meeting policy, and then we adjusted that by the model's prediction of how that was going to change between the scenario and the base year. So as an example, you can see there from the probe data, we saw 3 hours per day not meeting the speed threshold. Between the 2030 no build and that base year in the model, the model was predicting an additional 2 hours a day that would not be meeting the threshold. So combining in a way the observed probe data and the model delta or change in conditions, we get our best projection of what we think the hours a day would be under that future scenario. So 2030 no build be 5 hours. The 3 we're observing now plus the 2 the model thinks are going to be added over that time, and that's our future projection. It would not be meeting our 4-hour threshold. And I'm going to hand it over to Peter for a few minutes here to just tell you, kind of take you slightly under the hood of the model and why this is a little bit of a challenge for the model, and why we continue to use the big data where we could.
Great, thank you, Joe. Oh, Joe, I'm getting a bit of feedback up there. Perfect. So yeah, I'll just spend a few slides talking about some of the issues that we run into when we take very high resolution data like the INRIX data, high in both temporal and spatial resolution. And we try to match that with something like our model for our forecasted model data, which is much lower resolution, both temporally and spatially. So because this is a regional analysis, we had to use our regional modeling tools. And our primary workhorse is the Regional Travel Demand Model, RTDM. It's a standard four-step aggregate trip-based model. There's kind of a diagram on the left here of how those models, the various steps of those models work. But the key thing is that the final assignments are static assignments, static aggregated assignments. And this same analysis could be done with a more detailed, higher resolution, like microsimulation or mesoscopic simulation, but that's not practical at the RTP regional level. So we're working with static assignments. Next slide. Joe. Great. So what are some of the, I'm talking about the static assignment, but we refer to it as part of our regional travel demand model. So I'm just going to refer to it as regional travel demand model, but really this is specific to the static assignments that are part of that model. So some of the limitations of the model. They only assign trips to whole hours. So all of our assignment periods are for an entire hour. And they're for the whole hour, so noon to 1. It's impossible, or it's not. We don't currently do modeling like 12:30 to 1:30 or 12:15 to 1:15. We're set up in whole hour slots, 1 hour for every 24 hours of the day. And essentially we end up with averages for that hour for the entire link or segment that we're looking at. And so this makes it difficult to capture congestion that might occur over multiple time bins. And so, for example, if you have congestion that occurs in real life or in the INREX data between 5:30 and 6:30 p.m., the regional model the static assignments might show 2 hours of congestion from 5 to 6 and 6 to 7, or it might show 1 hour of congestion, either 5 to 6 or 6 to 7, or it may show 0 hours of congestion. So this is a disconnect that we often have with you relying on these more aggregate tools. Next slide. This is more of a comparison of some of the temporal and spatial limitations of the regional model compared to the INREX data. So if you look at this this diagram, we have kind of a sample, an example of a freeway, a throughway section broken into 3 segments. And we have examples from both observed or the INREX data and our model static assignment results. Just assume that the blank space means that traffic is flowing at or above that threshold speed. And if it's red, yellow, or orange, it means you're below that threshold speed. And what you can see here is that in the observed data, we're able to capture the queue that begins in hour 1 at the output end of segment 1. And as you progress through hour 1 into hour 2, you can see that queue spilling back. And eventually by the end of hour 2 into the beginning of hour 3, it's spilled back to a secondary queue that's beginning to form at segment 3. And segment 3 has its very similar form as segment 1. It just happens a little later in the day. If we move to the second part of this diagram, we show the model data. So here's where the limitations really start to stand out. In segment 1, because we're capturing congestion, you're either above the threshold or below the threshold. It's kind of binary. By hour, the model data is showing 3 hours of congestion relative to 3.5 hours that were observed. we move into segment 2. Another limitation of static assignments is that they don't do a very good job of capturing congestion due to queuing effects. So the upstream queuing that would eventually spill back into segment 2 is not necessarily captured in our static assignment. So in segment 2, we show 0 hours of congestion through the static assignment. And then segment 3, we come up with 2 hours of congestion, which is very similar to the observed, but you can see the pattern is a little bit different than what we see in the observed. So what this leads us to is that the model can underestimate congestion related to bottlenecks and may have different temporal distributions of that congestion. And yes, so this is an example in the real world of where we notice this. So this is I-5 northbound. This is south of the interstate bridge crossing. And it's certainly an area that experiences congestion due to high volumes, but also congestion related to spillback from upstream congestion occurring at the interstate bridge. And so if you look at the solid line, you can see that speeds stay relatively consistent until about the noon hour and then drop off quite a bit through the early evening and don't recover until about 8 p.m. in the evening. In our model data, we show congestion starting to build, but then really coming to a head at the 2 o'clock period and then dissipating by 6 to 7 p.m. So there's a disconnect here in terms of the temporal time frame of congestion that we're measuring, but also in the overall extent of that congestion. As you can see by the solid line is much lower than the dotted line. Next slide, please. So how do we reconcile these differences into something that's meaningful in terms of evaluating how congestion may grow or change into the future? Well, as Joe showed before, it's simply a matter of measuring the deltas that we see from the model and applying those deltas to the observed base year. So in this example, if we look at the base year model, we 3 hours of congestion for segment 1. In the base year, in the future year, that turns into 4 hours. That's a difference of 1 hour. We can take that 1 hour anticipated growth in congestion and add it to the observed base year hours below the speed threshold and come up with a 4.5 hours of forecasted congestion at this location. So we're taking the observed congestion from the RIDIS data, the INRIX data, and we're calculating how much we estimate that congestion to grow over time using the model. And you can just follow the formulas for each one of the segments here in this example. And let's see, is that it, Joe? I guess I'm passing it back to you.
Don't say that's it. That was a lot, but yeah, thanks, Peter. Yeah, I'll toss it back, and I'll watch the time here. I want to be sure we have some time for Q&A, so I'll just give you some quick hits from some of the initial results of our first time really running this region-wide in the way that Peter just set up there. So you'll kind of see, so on some maps like this, one thing we noted was that there was a reason, like Peter said, we were leaning on the observed probe data for the baseline conditions, because that it's something that's measurable. It's going to likely be more precise than the model, and most of the time. And so one thing we noticed is that there was a lot of agreement, between the model and the observed data, but there were also locations where they really diverged in that baseline estimate, and initially we flagged those, and it was really helpful to do that. Where there was a 4 hour or greater difference in terms of hours under the speed threshold, we kind of we flagged and showed those as these dotted lines you can see. Now in the final policy work or the public facing documents, these we ended up scrapping because it was just, it's confusing to the average person that doesn't even know what the travel model does or any of this stuff Peter just showed you. But it was really useful, and I think things like this it's worth seeing where the model really diverges from reality when you have a measurement, and it gives you a much deeper understanding of what's going on. So I will proceed through. So just from the observed probe data, you can see this is its view via this performance measure of Portland's throughway weekday reliability, where you see the colors, the blue or the red is more intense. Both of those, though, are not meeting that policy. They're more than 4 hours a day, that the speed falls below our threshold. The gray roads, which I know are a little hard to see here, are meeting that threshold. Doesn't mean performance is perfect, but as you see, this is doing a better job than that sort of pegged volume to capacity fuel gauge that we had in the past. So it was good to see, it's in the range of the measure the conditions we're actually seeing, which is more useful to policy. This is just a chart version of a system-wide summary. So we also did some system-wide summaries just to understand the measure and conditions, and you can see by scenario a sort of percentage of miles in the regional throughway system that were not meeting that performance criteria, no more than 4 hours a day, where the speeds are falling into that unstable range. And you see it starts at about, I'm going to focus on these orange bars, which are the controlled access facilities. And starting around 20% of the mileage in the regional network is not meeting that criteria. And of course, it grows in the no-build scenarios to a prediction from the combination of model and observed data to around 45% in the 2045 no-build scenario. Nothing's done. That's not already in progress. In the model, in the financially constrained scenario, that last one, which represents our best guess at what investments will take place, you can see, it's sort of holding the line in terms of this performance measure, a little bit pretty close to the baseline conditions. Now, that of course includes things like pricing and many projects, which are never certain, but it was showing us that it's giving us some useful information about how plans and policies are actually impacting the system. So that was good to see. An interesting outcome of this, we looked at facilities that weren't meeting the criteria, and we noticed that there were some consistent patterns among them, and we pulled that out as something to chew on a little bit and to think about from a policy perspective. That we were seeing these two that stood out, these two typologies, and one of them is in the first one where we have a midday and a PM peak congestion pattern. Right? So this represents some facilities, including parts of 217. In this one at the right, we see this all-day congestion pattern. This is a different typology where speeds drop during the AM peak around 6 a.m. and they don't recover until after 6 p.m. After 8 p.m. in the evening. Excuse me. So it really is a more than 12 hours a day where the speeds are in that kind of unstable or range. Interesting to think about that from a policy perspective. I'm just going to show you one. So we did these comparisons for all our different RTP scenarios, but this is one of them. So you see the no build on the left, and again, both the blue and the red are showing areas where we're not meeting the threshold. On the right-hand pane, you see the difference with the financially constrained policies in place, including pricing, the interstate bridge replacement project, and some other major projects in the region. And so, this is where it becomes that identification of need. You can see where our policies are making headway on the performance measures and where they are not. And so, those would be areas for further study, including Highway 26 in and out of downtown, Highway 217, and still pieces of 84 and 205. You can also think about it as a delta, from the base year. So this is the 2045 constrained scenario change from our 2020 base. So kind of understanding how conditions are changing relative to those hours per day under the speed threshold, where the blue things are getting better and the red things are getting worse. So sometimes, individual facilities have their own, local phenomena that make it hard to say ever meet the threshold, right? Just because of constraints. But sometimes it's helpful to just focus, I think, on the delta. Is policy pushing it in the right direction, even if we're still not able to meet, where we would like to be. And this final point before I stop and open it up to any thoughts from the room. Like I said, we're feeding this back into, we're putting it on our wish list for model improvements. We're going to look more closely at some of these areas where the model in the base year disagrees with the probe data. Probe data is not perfect either, but it's worth looking into. And so what you're seeing here in each of these quadrants represents the model on the y-axis, hours per day under the threshold, so congestion getting worse, and on the x-axis, the observed hours getting worse. And so in the lower left and the upper right is where the model and the observed data are agreeing, and they're both saying the same thing about giving you an up or down on whether it's meeting the threshold. In the other two, the upper left is where the model is actually predicting more congested conditions than we're observing on the ground. In the lower right, it's the opposite, the maybe more expected one because of what Peter said, where the model's kind of under predicting congestion on particular segments, and all of those that are not filled in are places we've flagged to go back to later and try to understand what is it about local conditions, model limitations that's causing us to kind of miss more than we would expect versus the closest thing we have to a sort of ground truth. So that's kind of where we are. I glossed over a little bit. Another thing we are looking at is we'll probably revisit those signalized facilities. It's tough to define a one-size-fits-all metric because they're so unique, an urban arterial in different locations in the region. And as some of you with sharp eyes probably notice, most of them were meeting the criteria most of the time. That criteria is pretty low, 20 miles per hour average speed. So that's what we're working on with this. I think we were pleased with how it came out. We learned a lot from it, and I think it gives the planners and policymakers at Metro a new tool in their toolkit that's a lot more nuanced than the old volume to capacity ratios. I also want to take a moment to thank Kim Ellis at Metro, instrumental in this entire process, which we were a small part of, and also Glenn Bolin at ODOT Region 1, who really worked closely with us to refine and develop this methodology. So, and thanks all for your time. I hope some of this was useful to your thinking about your modeling your regions.
So I know that we're over time, Liming, but if Joe, I'm just wondering, could you go real quick and show the no build versus the constrained? Because there's a lot of questions in the chat regarding pricing, tolling, and whatnot. And I just want to emphasize that essentially this no build versus the constrained is a comparison of a price, no price scenario. Far and away, the RMPP is the most significant project in the RMPP or in the RTP in terms of its impact on traffic. And so if you just look at the no build versus the constrained comparisons here, you can see the impact that pricing is having in terms of congestion management on I-5 and I-205. IBR and the I-205 Abernathy Bridge replacement both have tolls as well, but those impacts are more local. RMPP is a much more regional scale, and so that accounts for virtually all the change you see here in this comparison.
Sorry, you're seeing this presenter via Teams is not letting me share the bigger screen, but yeah.
Great, thanks for the clarification. I think there is few back and forth in the chat for this that haven't paid attention. It's basically what's included in the no build versus the constraint scenario. So since we are right on time, certainly feel free to still chat all those questions. I'll probably move on to Zach's presentation. So our next presentation is about CFAC climate friendly and equitable community VMT performance measure. Zachary will share an example application of the CFAC VMT performance measure, use a travel demand model along with an overview of the VMT calculation methodology. Zachary Harrowitz PE is a transportation analysis engineer with Oregon Department of Transportation's Transportation Planning and Analysis Unit. His professional background includes designing, analyzing, and managing a wide variety of multimodal traffic engineering, transportation planning, and transit projects for public and private sector organizations across the U.S. In his current role at ODOT, Zachary helped Oregon's metropolitan areas implementing Oregon's new CFAC program per Oregon's transportation planning rule, including working with a broad group of public agency stakeholders to develop new CFAC modeling guidance for Oregon. With that, I will pass on to Zachary.
Okay, thank you, Li-Ming. Can everybody hear me okay and see my screen? All right, excellent. So again, thanks for having me today. I was really trying to think about what to present to this group, and I had an idea a couple of weeks ago when Carol reached out to me that was related to our performance measures work that we're doing. There's obviously a lot of impact from the new transportation planning rule, ongoing work with the Oregon Highway Plan, obviously this implementation of the CFAC. So I thought about what to do and tie it into VMT, and we actually had some good presentations earlier today already that sort of talked about some of these elements. And I was thinking, we use speed or we use volume to capacity ratio, some of these long-standing performance measures to evaluate our system, but let's come up with see if I can come up with a hypothetical. Maybe it's not totally hypothetical. We can be optimistic that it could happen, and then use the idea of VMT, whether it's VMT per capita, as a performance measure for a specific type of project that I want to share. And like I said, this is really a bit of a hypothetical presentation, or I guess sort of presentation, but I do want to use it as a way of generating conversation with so many of the people on the group, and it's great to have such a large group today, so we can talk about some of the things that we might have to do if we want to use VMT as a performance measure. Okay. All right. So I'll talk a little bit about the problem statement and cover some givens.
Zach,
yes.
Would you mind put in the presentation mode so we have screen. Yeah, great, perfect. Thanks.
Okay, thanks. So we'll talk a little. I'll give you the problem statement and the givens I've sort of come up with, and talk then sort of the supporting policy framework that gets us to the selection of VMT as the performance measure, and then spend a little bit of time on some scenario development and the analytical process, and then I'd like to leave up plenty of time for a group discussion. So with that discussion, a lot of it hopefully will either be, this is a great idea, I think it's workable, or this is not going to go at all, in which case I think we might learn a lot about the applicability of VMT per capita as a performance measure. Also interesting to tie it to Metro's regional performance or mobility policy. All right. So as many know, especially if you're in the Portland area, we're going to get a new baseball team. I'm a big sports fan. I don't want to make this just sort of about sports, but it really could be anything else. And there's been some talk about having a stadium in a couple of different locations, and it seems that the Zidell Yards over on the South Waterfront is the top place for doing this. And now we're talking about, well, how do we get all these people and all the traffic to and from the stadium, for whether we're talking about baseball or these other things. And there's lots of ways of doing it, which is typical for any sort of large stadium. We're building new infrastructure, we're managing operations and capacity from what we currently have, we're bringing in transportation options, and there's a whole list of other ones. Part of the transportation planning rule is the selection of key performance measures, or even standards to a certain sense. And we know that both Metro has that as one of their mobility policies, and we're saying that on the assumption here that the city of Portland, out of all the different things they can use to measure the transportation system related to this new stadium, they're going to select the key performance measure of VMT per capita. It's not really per capita in some ways. We can talk about it per seat, but when I'm saying VMT per capita, know that we're sort of measuring it based on the people that are coming and going to the stadium. Okay. So some givens here just a little bit of the context where everybody is. So you see, here's our Portland region. This small orange dot is roughly where the stadium would go, or is currently being proposed. The Oregonian have this really great series, at least online, of all these different stadiums sort of shoehorned into this tiny little site that you see is sort of bounded on the east side by the Willamette River, on the north by where the Orange Line and the Tilikum Crossing across the river. West side is Interstate 5, and then on the south side is the Ross Island Bridge, US 26. And then a lot of the South Waterfront OHSU development is further south. I don't know exactly how we're going to get a stadium in here, but this has sort of been the proposal. Thankfully, Portland is one of the smaller markets for this, so maybe we'll be able to sort of get it in. But we're going to go with this for the time being. All right. Took a look. Most stadiums for the city size of Portland between 5 and 40,000. Baseball has 160 games a year, so 81 home games. This is not preseason or postseason. And with a stadium this size, we're definitely going to be able to get Taylor Swift and some of these other concerts that seem to sort of miss Portland because we don't have a large enough venue. So this is something that's going to be used not just 81 plus times a year rather, but maybe 120, 150 times depending on what we're doing. We know as travel modelers, a stadium is certainly constitutes as a special generator. And it's creating new demand, right? Both locally in the Portland area, regionally within the Portland metro area or Vancouver, and even possible statewide travel demand because there's only so many baseball teams around, and people that live in Medford that now have to travel to San Francisco to see the closest game or be able to come up to Portland. Because of the tight location, there's not going to be a lot of opportunity for major infrastructure development in terms of like widening highways or adding new interchanges. It's a pretty tight location. If you think about some of the other spots, whether it was in the Lloyd Center or at the Red Tail Golf Center, these are a major questions in terms of being able to get people to and from. And maybe my largest assumption here is that we're going to have some alignment. We have alignment on all the different jurisdictions, whether this is Portland, Multnomah County, Oregon, Metro, that we're selecting VMT per capita or VMT per seat as our performance measure. That's going to be the number one thing we look at when we look at a number of scenarios for measuring travel to and from the stadium. Okay. Briefly, a little bit of policy framework, where this VMT per capita is coming from. We are all familiar to a certain extent with the local, regional, and statewide plans, whether it's the Climate Action Plan or the Climate Smart Strategy, the mobility policy for Metro, and obviously the work that I'm doing with so many others at ODOT from the statewide transportation strategy all the way down to the TPR and the climate friendly and equitable communities. So VMT per capita is a major part of these. These plans also set carbon reduction goals for various other aspects of stadium construction, talking about all electric or building energy use, reporting on these type of things, but they also really focus on these policies, rather not specifically for stadium, but generally for any of the work we're doing in our region, also have that focus on transportation and land use. So a little bit more how we get to VMT as a performance measure. We have the Oregon Administrative Rules, Section 215 and also 905 that cover performance measures and the adoption of local performance standards. We're not going to be using a standard here because we're not saying that the VMT per capita has to be 50% below the average elsewhere. In the Portland area, we don't have a target to meet. We're just saying that we're looking to come up with a selection of a scenario, given all of the other trade-offs we have, cost and congestion, where we're looking to minimize vehicle miles traveled in terms of getting to and from the stadium. And like I said, that could be on a sort of per seat basis. But ultimately, where we're going to try and come up here with scenarios that create different amounts of VMT, and then going through the modeling exercise, which I haven't done, so I don't want to get anybody excited that I've gone through all this special modeling work. But I do want to talk about what can we do, or what could we do if this were to come to pass. But ultimately here, we're saying we're not worried about congestion on I-5. We're not worried about equity. I mean, these are all of these trade-offs, but we're really focusing on how to minimize vehicle miles traveled. Okay, and I'm saying as a connection to some of the other performance measures that might relate to aspects of stadium construction, we're talking about households that can be located within transit that are accessible to the stadium or within the stadium. There's aspects of, obviously, we're going to be paying for parking. There's some percentage of construction budget that can be spent on supporting or building infrastructure for low or no carbon modes of transportation. The stadium area around it to develop it with a pedestrian bicycle level of traffic stress that's very conducive to that kind of work. Obviously, getting people to and from the stadium safely is also sort of very important. So there's some connection here between the VMT per capita measure and the performance measures that we're looking to do at the regional level per the target rule. As I mentioned before, we have some infrastructure challenges here, mostly related to the constrained site and the limited type of freeway or arterial connections. Again, we have some of them, but this is not, some greenfield development out on the edge or some of the stadiums you see elsewhere in the United States. The area is currently congested. Most ball games are happening in the evenings or on the weekends. This section of I-5 and down in South Waterfront, it's fairly dense already. There's a lot going on, and now we're adding all this new traffic. There's not much parking down there. What I mean down there is South Waterfront. We also have some question about how much room we want to build, or how much room there is to build more for that. These neighborhoods, especially the South Portland one, has seen over the last 100 years lots of changes as far as transportation, and that's certainly affected neighborhood livability, sort of cut up the neighborhood in a lot of different ways. Obviously, through the development process, maintaining the emergency first responder access is key requirement, and clearly freight movement, whether we're talking about bringing concessions to the stadium or getting Taylor's concert set up is a key consideration. On the flip side, we have a lot of opportunities and a lot of our mobility assets, which is part of the reason this site was selected. So the Tillicum Crossing, this non-motorized bridge over the Willamette that carries all those different modes. We have a higher capacity transit system, whether it's bus or MAX. We have the tram. Obviously, this is an area that has lots of great pedestrian and bicycle routes. There's micromobility options. We have opportunities for some sort of park and ride, whether to use the downtown parking garages or even sites elsewhere, possibly on the east side. And even though we don't have necessarily direct freeway connections, we have a lot of connections close by, again, mostly in downtown. There's opportunities for the transportation network company. Maybe we could set up a water taxi. There's lots of different things we can do. And again, part of the challenge that would come to evaluate this is how do we incorporate all of these things into the travel model, or even can we? So getting to the scenario development. And these are some of the questions I want people to think about so we can discuss. So some of the elements are, can we model? So we know that our travel model can definitely cover the local and regional access. But when we're looking at longer distance travel, people coming from the southern part of the Willamette Valley or elsewhere in Oregon, are we going to be able to model this? Is this something that the statewide integrated model can be a part of the project to do this? Transit, again, something that's part of our travel model already. We can do that. We need to sort of look at different ways of incorporating those capacity and operations. We have pricing policy, whether it's parking, is there a cordon pricing measure we can do to get into the zone as a way of really reducing the desire for vehicles to get there. Also, questions on, in terms of some of the development aspects, would it be possible, along with the stadium development, to also include some measure of housing? And I'm not talking just 100 or 200 units, but maybe something like 2,500 units. I'm just putting out numbers here that can include public work for housing, not just for construction workers, but for people that would be working at the stadium or for the team or the other related businesses there. Elsewhere in South Waterfront, again, these folks can walk or bike to the stadium. That's going to reduce the amount of travel needed. There's always the potential for mixed use and freight movement, which of course is limited. And there's also these travel option programs. Again, the question here is, what can we do in terms of developing multiple scenarios to test out to try and find one that might actually reduce VMT or provide a minimal amount of VMT relative to some of the other ones. Really thinking about some of the analytical process. Again, just putting some ideas out here. Do we have data to support some of this scenario development as a VMT performance measure? Even practical aspects of the model itself. Do we need one TAZ to represent the entire stadium? Do we need other ones to sort of to break it out? Do we look for a model scenario that effectively is our sort of our no build or our worst case scenario, where we have like 20,000 parking spots? I know it's not realistic in terms of the actual infrastructure, but could we assume that to say that basically, even though it's a very tight location, we could assume near 100% auto mode share to the stadium, just to see what that would look like in terms of VMT and work backwards from there to try and minimize. I know, and I apologize to Tara here, who's been spending so much time, like we all have, really focusing on this household-based VMT. But one of the benefits of VMT, and for folks that are familiar with that Fair and Peers graphic that shows 9 different ways of measuring VMT, this one would be one where we're not really looking for household-based per the definition in Division 12, but actually measuring the actual on-road vehicle miles traveled. And work to try and minimize that. So we have an option using the performance measure to actually not use the household-based definition if we're looking for a specific project. Okay, just a couple more things here to sort of work through. Again, putting out some ideas. We look at, I know we've done trip caps when we've done smaller area plans like out by the airport. Could we do something also for VMT in terms of as development proceeds, making sure that it's not over a certain amount? How do we measure the travel through all modes to make sure we're incorporating this? Do we have to do some off-model work due to some of the limitations of our trip-based model? Or maybe do we develop an activity-based model specifically for this type of evaluation? Can we capture park and rides for off-site parking facilities? Do we capture people from the airport? What time periods for analysis? Again, a lot of games are in the evenings, but we also have Saturday games, Sunday games. Do we look at multiple ones and try to minimize it across all those aspects? Do we look for summer months, which is sort of the main part for baseball? Or is it a combination of all these things? Again, a lot of questions here on how to do this particular type of project. And then getting to the methodology, again, I do want to spend a little bit of time talking about the overall methodology that we're getting close to wrapping up. But for this particular project, this hypothetical, obviously we're going to use the regional travel model. I would like to see an opportunity for SWIM to try and capture some of the statewide or external. Again, there's also cases where measuring VMT on non-game days when people are actually working at the stadium. How do we measure that? How does that get incorporated in? And in some ways, I really would like to hear from our group to find out, if we were to do this, do our existing modeling tools, whether it's the ones that are currently in place or ones we could implement if we needed to do this, are they sufficient to a certain extent, given some of the other ways of doing the analysis, to look at and get to this result for this hypothetical situation? And if it does not, or we don't think that's the case, do we really feel that making that using VMT per capita as a performance measure as applied to a specific project, whether it's a development project like a new stadium or even a particular transportation project like the interstate bridge, does that render it somewhat infeasible, at least within the context of Oregon's transportation planning process? And I think that's the last one. So I'd like to just turn it open now for some discussion and see what we got. Now, again, I'm asking everybody to think here and come up with some responses to my crazy idea. But again, this is something that we have an opportunity to do. We know, and actually Cody referenced this with the CAPCOA stuff, that California, because of their land use process, does some of this VMT type of analysis for large housing developments and other land use modifications elsewhere in the state. But I do want to hear from folks to think that this is not going to work or it's going to work. But so with that, I'll be quiet. I hear somebody from TriMet staff who obviously would play a very important and critical role in this.
My name is Catherine, and I've been paying attention to Providence Park, particularly tapped by our public-facing professionals who negotiated a partnership with Providence Park, the ticket as fare program. So basically, Timbers games, Providence Park has 0 parking, and yet people still go. And I think it's a really important and valuable example to use in the imagination for a baseball diamond. So people were using TriMet, some people were, to get to the matches, but after there was a partnership with the stadium owners, there could be more messaging around take the max and oh look, you don't have to pay $2.80, but yet the program was pretty successful, and there was roughly a 50 to 60% uptick in what we saw in ridership upticks before that program. So I just think it's whether that would happen. I could foresee that success persuading, I don't know, Mr. or Mrs. Diamond Park owner to be motivated for a similar partnership. But I just know that something like that sort of program can make a difference, but be hard to include in a model. But it was a really fun analysis for me to work on, and I think the concerts, Foo Fighters and someone else, Green Day, those are really successful. But concerts have a much larger freight equipment presence for some of these big shows, and so actually the problem operationally was oh no, these freight trucks are kind of disrupting some of the transit flow. I wasn't there on the ground, but that's what I heard. So it was just there's some insight from a TriMet nerd who's been paying attention to big events at Providence Park.
Yeah, I think that's a great point. And, I certainly was thinking, actually, I hadn't thought about Providence Park. Obviously, that's something that's already existing. So it's working with the infrastructure around it. And certainly there's examples of baseball stadiums, whether, Wrigley Field in Chicago or Fenway Park, that are in these cities that are, several hundred years old, also without a lot of parking. I think one of the things I'm getting from what you're saying is that if there is a desire to try and meet our multiple policies that try to reduce climate pollution, and we know that we're getting some type of development here, that there has to be this optimism and desire at all levels, whether it's from the development side as well as all the different regional partners that are providing these services, to try and make this work. That we can do it, but we have to test it out. We can't just sort of pretend that it's going to automatically work. And I think trying to come up with some of this, some of these tests would be, I would hope to have it as a requirement. And I keep thinking for TriMet, is there a way, is there even enough capacity on the max to get these thousands and thousands of people to the stadium with just that line, again, with streetcar and the rest of that? What does that end up looking? I'm not asking for any answers here, right? This is something that would have to be studied, but can we do that? Is that even possible? And if it is, can we model it and see if we can actually get those empirical results?
Yeah, certainly the Providence Park is fed by the east-west blue-red lines, which are already like the heavyweights in terms of ridership. The north-south yellow-orange line that is close to the baseball stadium are generally the lower two of our max ridership. So it is interesting to see like how it's easy. I think it's easier to get a transit adoption when there's already a ton of people who are familiar with blue and using blue and red lines. It might be different for yellow and orange, but yeah, like measuring or trying to account for the elasticity of like a successful promo is, I think, an interesting challenge, all things considered.
Right, because if you're coming from Clackamas County, in some ways, if you're going to the game, you really should be parking at the Orange Line terminus and then taking the train in. And how is that promoted? Is there a way of capturing that, right? Because you're still driving to that point, so that's some VMT, but you're reducing that last like 3 miles or 4 miles from that point to the stadium. And that times 5,000 people is a substantial amount times, 150 events a year or something like that. Eric.
There we go. Hi, thanks, Zachary. Our team here is excited for the hypothetical, especially Brian, who's a big baseball fan. So he's getting really excited. Though I think I'm here getting slightly, and I noticed we've got a few. I know this is an OMUG space, so not a formal CFEC implementation space. But I guess I also just wanted to clarify, as we were on the cusp of our transportation system plan here at the City of Portland update, that we're more really, and I do actually would love the group's take on sort of how well the existing toolkit can help analyze this. But I guess maybe, Zachary, I heard you mention maybe a linkage to the regional mobility policy in your introduction, but I'm not sure I heard that in the presentation, because I guess my sense is we don't need to do CFEC VMT analysis in our TSP right now on this, at least not at a project specific basis necessarily, unless we're maybe doing an 0830 roadway expansion to do it, but like this isn't quite a reality yet, but maybe might come in more under a plan amendment concept where the regional mobility policy is also asking us to look at VMT per capita, and this is how we would then sort of try to implement that. Is that maybe the context in which you're thinking about how this is responsive to some of the rules, even if so anyway, I guess that's one sort of just question in terms of how does this hypothetical fit into what we're actually doing in the next year, to make sure I'm ready to deal with that.
Right. Well, as you said, Eric, it is a hypothetical, but yes, I actually feel that what you just said is exactly the linkage, right? Because this would be some sort of plan amendment, but also the fact that Metro has adopted this mobility policy too. So we know that VMT as a performance measure is something we're looking to do. And it's not to do when you're translating, when you're changing just a zone from, it can be applied at the big level, and this would be a big type level. It's the same way you apply it at the jurisdiction for the TPR.
Right, and I guess maybe just my head is going back to the regional mobility policy and the way in which that plan amendment work is then tending to address this district-based VMT baseline, and I guess I'm just not seeing that engaged here. So maybe that's one other wrinkle to the process, and maybe Kim can speak to that. Not to put you on the spot there, Kim, but I think that's why you're on. Because I think that was part of what we were trying to understand is how those districts were getting defined and how that then worked within the TAS systems and things like that. So I think that's one other angle on the implementation under at least the regional mobility policy that I think needs to be addressed.
I can speak to that if that's helpful. Yeah, so we have been working with Zachary and other staff to begin developing sort of those baseline measures. So they've handed off a methodology that was developed as part of some of the many folks I think that are on this call that was led by Zachary, and then we're going to be working with them to begin generating some of that information. So I'll be able to give more of an update in January, but we're working internally to get that. we'll have to vet that internally, make sure it's working the way that the methodology that was developed by Zachary and others before we start sharing that. But that work is underway, and we expect to have something to share. Peter's going to be leading that work on our behalf in the coming months. So
appreciate that update, Kim. I look forward to January. Thanks.
Yes.
Yeah, one other thing about this, again, hypothetical example, hopefully actual example, is that as all of us are practitioners or involved in policy making, I do feel we have a bit of a personal responsibility and professional responsibility to provide the technical responses, technical tools, and answers to the folks that will be making these decisions when we're sitting in the various meetings. And sometimes it's about asking the right questions. Sometimes it's about providing, unbiased and objective data, all those different things. But we also have like I said, that's on us, right? We may want to make the decisions, but we don't necessarily are in the same seat as those folks. But we do can provide this information and really provide those that engineering and planning lens in order to help people make and meet those policy goals that we've all set up from our public engagement aspect.
Yeah, no, I appreciate that, Zachary, and sort of, maybe the floor of regulatory requirements is one thing, and then there's good practice, and certainly here that I appreciate your asking the questions here about what can we do with our tools, and how do we need to evolve our tools as we try to get more sophisticated in analyzing these types of things that we do hope happens. So,
right, and you're welcome. And I know we just have a few minutes left, so I want to just say again, thanks everybody for sort of listening to this thought exercise. Give somebody, on a Thursday, get those wheels spinning.
Right.
But we do have a lot of chances to do this. I know we're going to get over to the announcements in just a second. And just to build quickly, if I may, Li Ming, we do have our VMT methodology. We're working through one last thing related to the always challenging non-home-based trips within the trip-based model. So I'll have an update for that. But we do have a document that we're just putting the final touches on. I sent it to Kim and staff at Metro, but we can use it, and we use it now on a number of other applications. So we're ready to go as far as
okay, great. Thanks, Zachary, for very thought-provoking hypotheticals. Tara also commented that there may be different definitions of VMT that only plays into that too. Closing down for today. So the final section is an announcement. Some of you may be aware, at least we are have a change of guards for the OMUG coordinating committee. Kyle and Garth are departing. Especially Kyle is stepping down after serving in the committee for 15 years. So we certainly appreciate his service, and I believe he actually initiated this OMUG committee 15 years ago. Thank you, Kyle. I'm not sure whether you want to say a few words.
No, I'll just say, I guess, yeah, by unmuting myself, I'll just say a few words. Yeah. Thanks, everybody. I would love to take credit for starting OMUG, but, I'm old enough to know here, have been around here long enough to know when Ray Jackson was sitting in this seat, and even at one time Joel Friedman. So this is something that has been around for longer than me. I was fortunate to have time to carry this through and change formats, and it's evolved so much. And been very productive part of my workload, at least. And I think it's been a great communication advice. And I think the leadership that has been appointed here through Joe and Chris and continuing Li Ming, it's just going to make it that much stronger. So, and Carol as well. Carol, I don't want to leave you off the line, because you've been instrumental in moving this forward too. But back to you, Li Ming, and thanks everybody.
Okay, Thank you, Kyle. And of course, Garth is also stepping down after a 2-year helping steering the ship for the OMUG. Appreciate both of you for your service. And Joe and Chris. Joe, I believe Chris was here a moment ago. Joe, of course, just present this morning, will be joining or leading the coordinating committee along with myself for the next 2 years. And certainly looking forward to working with both of them. So next slides, we do have the programs for the coming year or so. We will bring back our post-TRB Brown Bag. We'll host it, I believe we'll still host it at PSU. So if you're going to TRB next year, next January, certainly keep that in mind. Hopefully you will join us afterwards to share your takeaways from the TRB. And we 3 additional events that's on a schedule right now, performance measure and standards part 2. We actually originally think about organizing 1 session, but there are many more than we can put together or can accommodate in 1 session. So we'll do a part 2 sometime next year. And we will also decide, this has been postponed once, to do a session on vision eval, overview and application sometime next year. And then hopefully in the fall 2025, we will do a travel survey report out. So this survey data should be released sometime next year. And then this will be probably a good time to get some initial reading from the survey. As always, we welcome suggestions. And if you have suggestions for events, feel free to reach out to either the 3 of us or to Carol, sorry, not Kyle anymore, Carol. And in terms of upcoming events that might be of interest to some of us, those are most likely an incomplete list. Again, feel free to share any announcement you may have from the group. So this might be a good time. Okay, hearing none, and we are, that's all for today. So as always, the record of the session and the slides will be available on the OMUG website, which you can find there. And thank you all for joining us today. Especially thank you for the 3 presenters for today's session. I hope to see you in one of our next events.